Lesson 90, Sets. A set is a collection of elements. They use braces. So we got to make sure that we have braces on our sets. Those are those pretty parentheses. Here's an example of a set. It's the set of whole numbers. So we start with the braces. Whole numbers start with 0, and they count up by ones. And we put ellipses at the end. That's those 3 dots. That means it continues the same pattern without end. So we're going to put the little definition here. These are called ellipses. And it means continuing without end. The notation, this little E symbol, capital epsilon, that just means is an element of. So if I wrote 4 is an element of the set of integers, that just means that within the set of all the integers, 4 is one of the elements. The way we read it is 4 is an element of the set of integers. 1/4 is not an element of the set of integers. So this is how you read it. 1/4 is not an element of the set of integers. We have symbols for each of the sets that we talk about. One is this N that has a double middle line there. That stands for the natural numbers. Another word for natural numbers is the counting numbers. It's just the numbers that you use to count with. So we put our brace, we have 1, 2, 3, 4, and a set of ellipses to show that we're counting by ones. A capital Z with a double middle bar is a set of integers. And that's written with braces, a set of ellipses to show that it continues without end on the left side. -3, -2, -1, 0, 1, 2, 3, another set of ellipses to show that it continues that way. A Q with kind of a straight lines on both sides, that is rational numbers. All rational numbers can be written as a fraction with a numerator and a denominator of integers. So A and B are integers. The set of real numbers is an R with a double line for the left side. These are the set of real numbers. The set of real numbers includes both rational and irrational numbers. Oops, it's parentheses. Okay. So if we were to make a table for real numbers, so this is all the real numbers, we're going to have rational numbers on one side and irrational numbers on the other. So remember, rational numbers are made of fractions. So all integers are going to be rational numbers. So inside here we have integers. All of them fit in this little area. Then within the integers, we have all the whole numbers. And within the whole numbers, we have the counting numbers. So all counting numbers are in whole numbers, all whole and counting numbers are also integers, and all of these are also rational. Irrational numbers are numbers such as pi, square root of 2, square root of 5, etc. We also have a set of imaginary numbers. These are not real, they are imaginary. And we use the letter I to indicate imaginary. That just means it's the square root of -1. Now we have this little c that turns like that. So it's kind of like the is an element of, where it has that e with the line through it, but without the line through it. So it's just like this little horseshoe. This is read a subset of. So a subset is just a set that is fully contained in another set. So we could say the set of natural numbers is fully contained in the set of rational numbers. Sometimes we use what's called a Venn diagram to show how things are related. So here's an example of a Venn diagram. We have a set of rectangles. We have a set of rhombuses. And in between, the set that is both a rectangle and a rhombus would be squares, all squares. So this part right here, the squares, that's called the intersection. So when two sets, and we use this symbol for intersection, when two sets meet and they have common elements, they will have what is common between them is called the intersection. So if we have our Venn diagrams, and it is this part right here, so it's common to both. It's in both groups. So if this is A, set of A, and this is set B, A intersection with B is where the two have common terms. So we would call this the intersection of sets A and B. Now the union is used like the horseshoe like that. It includes all the elements. So if I said A, or the union sets of A and B, that includes all the elements. And we only list them once in the set. So this is the union of sets A and B. That's how you read this. So here's an example finding union and using union and intersections. So if the set A has the elements 1, 2, 3, and 4, and set B has the elements 2, 4, 6, 8, we could say that the intersection of A and B is equal to, now this is just the numbers they both have in common. So they both have a 2 and they both have a 4. So that is what they have in common. If we did the union of sets A and B, that's going to be a list of all the numbers. So it's going to be 1, 2, 3, 4, 6, and 8. Notice that I only listed 2 and 4 one time. You don't have to list it twice. So this is all the elements in both sets, A and B. Now here's key. If there are no common elements, then the intersection, so the intersection of sets A and B, would equal the null set. It's a set with nothing in it. So you can do that with a circle that has a line going through it, or you could list blank braces with nothing in the middle. That's called the null set. And I do have a thing that we can tape in our notes. It looks like this, and so we'll get you that you can glue in the back of your notebook. And that's the end of the lesson.